Hi everyone, I am Manjunath HP, lecturer in physics, CNCPU College, Chitradurga. My dear students, we already successfully completed the first chapter of a prescribed syllabus, electric charges and fields. Now it's a time to move on to the second chapter, electrostatic potential and capacitance. But before entering into the second chapter, let us have a quick review on the concepts what we have learned in the first chapter. So the basic fundamental thing we learned, that is about the charge. Next to the charge, we studied the types of charges, and we have to remember that Cavendish law, where we are going to have the two kinds of charges. And we studied the concepts of gold leaf electroscope. You must remember why we are using gold leaves only there, so which gives the presence of electric charges as well as the polarity of the electric charges. And we studied the concepts of electrification, that means the process of charging a body. And we studied the types of electrification of a body, that is by friction, conduction, and one of the important method, that is without any physical contact, charging by induction. You must remember the steps we have to follow in the third method of electrification, that is charging by induction. Next to the concepts of that electrification, we studied the basic properties of charges. Very important. You must remember the basic properties of charges, that is additivity, conservation as well as quantization. And after the basic properties, we learned the very important, that is Coulomb's law in electrostatics. It gives the force existing, it may be the attractive force or repulsive force between the two point charges. Carefully you have to understand the statement, you have to remember the expression, and you must write the vector form also thoroughly. Okay, and remember the limitations. Just you have to recall all these concepts. Most important, that is a representation of that Coulomb's law in vector form. Next to that, we studied the force between the multiple charges, and we entered into the concepts of electric field, and we derived the expression for electric field due to point charge, that is equals to F upon Q, and we got the expression 1 by 4 pi epsilon naught Q by R square. That's it, where Q is a charge and R is a distance, where we are making use of source and point charge. Please recollect all these concepts. Okay, next we studied the physical significance of electric field. We studied the concepts of expression for electric field due to system of charges. We studied the representation of electric field lines around a single point charge as well as for combination of charges. Please draw once again all the diagrams for a point charge as well as for the similar or dissimilar charges. After that, we studied the properties of electric field lines. This is also one of the important question for your board examination. And we studied the concepts of electric dipole, where we must have two equal and opposite charges separated by a small distance. We must remember the definition of electric dipole moment. Next to the concepts of the electric dipole and dipole moment, we derived very important two derivations, that is expression for electric field due to dipole on its axial line, the second one on its equatorial line. These are very important derivations. Please go through these derivations. After studying those derivations, we also studied about the polar and non-polar molecules. We derived the expression for torque experienced by the dipole when placed in the uniform electric field. We discussed the concepts of that distribution of charges, continuous distribution of charges, and we are going to have three kinds, that is the linear charge density, surface charge density, and volume charge density. So next to the concepts of that charge distribution, we discussed the concepts of electric flux. In the concepts of electric flux, even we know area is a scalar, but we have to consider that area as a vector, and we must remember the expression for a flux where phi is equals to E dot delta S. That is delta S, we have to consider it as a area vector, and we must remember the angles for maximum as well as minimum flux. And we studied one more important law, that is the Gauss law in electrostatics. So the law states that the electric flux through a closed surface is equals to 1 by epsilon naught times the total charge enclosed by the surface. Next to the Gauss law, we have applications of Gauss law, and we have very important three applications of Gauss law. The first one, field due to infinitely long straight uniformly charged wire, which is related to linear charge distribution, and the final expression we are going to get, that is 1 by 2 pi epsilon naught lambda by r, 1 by 2 pi epsilon naught lambda by r, or we can say is equals to lambda by 2 pi epsilon naught r into unit vector. The second derivation, electric field due to uniformly charged infinite plane sheet, where we have to consider surface charge distribution, and the final expression we are going to get, that is E is equals to sigma by 2 epsilon naught, where sigma must be considered as a surface charge distribution. And the third application of that Gauss law, that is field due to the uniformly charged spherical shell, where we have three cases. The first case, that is field outside the shell, where we have the expression E is equals to 1 by 4 pi epsilon naught q upon r square. The second case, that is field inside the shell, as we all know that always the charges resides on the surface, therefore the field inside will be 0. So the expression will be phi is equals to 0, therefore E is equals to 0. And the last case, field on the surface, and the expression, that is E is equals to sigma by epsilon naught. So with these concepts, with this knowledge, we have to move on to the second chapter, where we are going to study electric potential.